Good morning, ladies and gentlemen. And today we're going to be looking at the sine law and the cosine law. And the first thing that I have to be very, very clear with you on is that the sine law and cosine law are different than the sine ratio and the cosine ratio. The sine law does not equal opposite over hypotenuse. That is a ratio. Okay, that's the sine ratio, not the sine law. And the cosine law is not adjacent over hypotenuse. That is the cosine ratio. And again, these are good for right triangles. These work in right triangles. These guys, much more powerful, are going to work in non-right triangles. Okay? So that's the difference between these, and we're going to open up the package and take a look at what we have. Okay, so I'm going to start off real simple. I'll do a bunch of quick videos, and then you'll have some quick practice, and then we'll put it all together. So, sine law, sides. So I'm only going to talk about the sine law in relationship to sides right now. First thing you need to know is if I have any triangle, a non-right triangle, I'm going to arbitrarily label it. So I'm going to call this angle A. This will be side A, little a. That's how we do things. If the vertex is A, big A, the side length is little a. So if this is big B, that's little b. And if this is big C, that's little c. And you'll notice that I denote my little case letters with a little bit of a tail. Okay, so the sine law. This is the way it works. If you have a side length, and if you divide it by the sine of the angle opposite it, it is going to equal another side length of the same triangle divided by the sine of the angle opposite it. And that looks like this. So you're going to get A divided by sine of angle A will equal B of sine of angle B, which also equals the third side divided by the sine of the angle opposite it. And there you go. That is the rule, the relationship for the sine law for sides. Notice that we have sides on top, and on the bottom we have the sine of angles opposite the given side on top. And that's the way it works. Now, I'm not a big fan of memorizing formulas. I do not want you to memorize these formulas. Those of you that come from grade 10 academic, I'm pretty sure your teacher said memorize the formula and fill it in. I'm going to tell you, do your best to forget that information. And let's just look for a pattern. So let's see what we have here. Here's your unknown. It's a side length. It's x. Here is the angle opposite it. So that means that x is going to equal, x divided by sine of 120 is one of the relationships. And that relationship will equal any other side, 25, divided by the sine of the angle opposite it. So it's going to equal 25 over sine of 35. That's it. That's your setup. That's worth a mark. Now the next step is to solve for x. So sine of 120 is just a decimal. Okay, so we need to solve this for x. We need to get x by itself. We're going to do that by multiplying both sides by 120. So that's going to look like this. If we multiply both sides by sine of 120, that'll reduce on this side, leaving me with 25 sine of 120 over top of sine of 35. And that's worth a second mark. Okay? So you can also think about this as cross-multiplying and then dividing both sides by the sine 120. Both work. In either case, you grab your calculator, and each calculator is different. You're going to have to make sure you know how to work it, but it needs to be in degrees first of all. So I have a little DEG for mine. You'll have a D. If you have an R or a G, that means gradians or radians. Those are the wrong units. It's another way of measuring angles, but with different units. It's kind of like the difference between measuring a length by kilometers or measuring it by miles. If I take the same distance from here to Toronto, I'll get a different number of kilometers that are in that distance versus a different number of miles that are in that distance. So we need to make sure that we're all measuring it in the same units, and that's degrees. So with my calculator, I do 120 and I hit sine. Other calculators, you'll have to hit sine first, then the 120. It's up to your calculator. Then I hit times 25 and I hit equals. So that's worked out everything on top. Divided by 35 sine on the bottom, but then I have to hit equals because this decimal is just the sine of 35. So equals, and I get a final answer of x equaling, now I'm supposed to go to 2 decimal places, so the 6 rounds the 4 to a 5, and it's 37.75 degrees. That's it. That's all she wrote. That's a 3-mark question. One for this, one for this, one for this. Off you go. Now, let's do the next one here. So I look for a pattern. Side, angle opposite it. Side, angle opposite it. That means that side, sine of 59, angle opposite, equals 90 over sine of 54, angle opposite it. That's all I need. Now, notice that this was the formula. The formula had A sine A, B sine B, C sine C. But I'm never using all 3 at once. I might use these 2 at once. I might use these 2 at once. I might use these 2 at once. I never really use all 3 at once. That's why there's only 2 here. Okay? This third side, I don't know what it is, and this angle, I don't know what it is. And frankly, I don't care. I have an equation here with one unknown, and I can solve that. So let's do this one a little bit slower than I did the last one. You certainly can do this one in the same 3 steps, but let's add a step or 2 just so that everyone sees where it's coming from. 90 over sine of 54. So let's look at the cross multiplying. So we're going to cross multiply both sides. That's going to give you x sine 54 equals 90 sine 59 over top of, oh, not over top of anything yet. I've just cross multiplied. Okay, so this came over here and multiplied there. This came over here and multiplied there. I've got x sine 54, 90 sine 59. I need to get rid of this sine 54. That's a decimal. So I'm going to divide it by sine 54. That's how I'm going to get rid of multiplying by sine 54. So I'm going to do the same thing here. What happens is these 2 reduce. That's why I did this, leaving me with x equals 90 sine 59 over top of sine 54, which again is this step here. So you don't have to add all this. You don't have to add all that, but that's where it comes from. So when I'm stuck with something like this, I notice my x and my sine 59, my 90 and my sine 54, that's going to come up here and give me 90 times sine 59 divided by sine 54, and that's going to give me a final answer of 59 sine times 90 equals, divided by 54 sine equals 95.36 degrees, rounded to 2 decimal places. Okay, guys, on the back there's some practice. You should do that now and make sure that you can do this, and we'll move on to the next concept.